What's up, you guys? Welcome back to the Monkey Cave. Here we are. This time we've got an aluminum project. So I wasn't quite expecting one of these so soon while I've been trying to film these YouTube videos for you guys and all of that. But we are like a job shop, so we take whatever comes in the door. So this is one of my friends. I've done some other tanks for him in the past. So he asked me to do this tank up for him here. He tacked it together and then he brought it up to me. That way it's assembled and whatnot. Of course, it needs additional tack welding. What I'm going to do is I'm going to get into some of the details as far as issues you might find with aluminum, some of the characteristics of aluminum, and then how to weld aluminum, right? And the different applications and different wires. I know there are guys out there showing you how to weld. You probably watched their videos already, and I definitely don't want to step on anybody's toes. You might not even come to me for this information, but I do happen to specialize in aluminum. I've been welding it for a long time. So I understand the characteristics and what it is about aluminum that people make the claim that it's difficult to weld. Realistically, we could just get right into the technical aspects, right? All right, so I'm just going to get right into it as far as the technical stuff goes. I'm a believer in keep it simple, stupid, so I will try to do that. Basically, when it comes to aluminum, you have your different grades of material, right? So say you've heard 6061 T6 aluminum, right? So the 6061 is the condition or the grade of the material by itself, right? So 6061 is a aircraft quality, right? Which means it's a real high grade aluminum with specific alloying elements in it. All right, that T6 condition that you hear about it, well, that's the heat treat in it, right? So there's 6 grades of heat treat, and T6 is the one that has been treated to the T6 condition. So there are also like lots of different ways to skin the cat, so on and so forth, right? But generally for general fabrication, non-aerospace, you're gonna deal with things like T6, 6061 aluminum probably pretty often, and then there's a couple other grades in there that you might use that are application specific. The cool thing about this is, like in the thinner materials, you can break it and bend it, so it's great for paneling on a truck, aluminum wheel wells and things like that. This 6061 is great for fuel tanks or water tanks. We'll just call them water tanks, okay, for safety purposes. That's what this is. It's the water tank. And so no chemical reactions with the petroleum-based products or any of that. It's a high-grade aluminum, so you weld it with a high-grade filler material. Obviously, we're sponsored by Blue Demon, so I got some Blue Demon filler over there, and I'm going to just share with you the two differences, okay? So you have your 4043 aluminum filler, and that's what you use when you're building tanks and things like this. And then you have your 5356, so that's real hard aluminum. So if you're repairing a cylinder head or something that's going to be machined, that's usually the filler you're going to go to for that. And then the rest are all very application specific. But generally, those are the two that you're going to deal with. So 4043 is a little bit softer, has a bit of give, so it's great for all the contours and things like that, and it still has a little bit of movement. So when it comes to tanks and things like this, you have to expect expansion and contraction, things like that. Different temperatures, different fluids, liquids, whatever you want to call them, they're going to expand this tank. And especially if you're building like something with like 2 tanks right next to each other, they're going to grow into each other and then they wear, things like that. So those are all things to stay conscious of as the fabricator. So this is a simple water tank. I'm going to weld it with some Blue Demon 4043. And that is what we're going to get into. Now, I will tell you a little secret, right? People talk about aluminum is difficult to weld, and it is, because obviously you have to have a machine that can run in AC, right? And then of course you have your higher end machines, they're even better, but this old dog right here is going to get down tonight. So you have to be able to weld in AC. Now I have welded aluminum in DC, but there are tricks to that, and that's application specific. Those are aircraft components. And what it is in DC welding, the aluminum needs to be absolutely clean as possible. You clean it, you clean everything, and then even then you're going to get contamination, and it leaves kind of that a disformal seam but it's usually used where you need a penetration in aluminum, because penetration is very difficult to achieve in aluminum. So the way I used to teach, when I would teach about it, is stainless steel has a very low thermal conductivity. Welders refer to it as like butter, right? So it's very smooth, it welds very nice. Aluminum is almost like an opposite of that. It has a high thermal conductivity. So if you weld this over here, this entire part is going to start to get hot pretty quickly. So if you're trying to rest on it and things like that, it's really not going to be all that pleasant for you. So those are things to stay mindful of, right? So realistically, the biggest adversary, if you're not aware of it, is the oxide layer. So when you're welding paneling like this, aluminum reacts with natural air, and that's really the trick. So you have to clean your aluminum very thoroughly. I'm going to clean all these edges before I actually weld this thing very thoroughly, and then you have time limits in aerospace before you have to clean it again, about 45 minutes to an hour, because that oxide layer, the aluminum reacts with natural air, and that oxide layer actually grows. So it will get thicker and thicker and thicker. Now you don't see it so much on polished aluminum and things like that, but if you're ever out and about and you're looking at aluminum and you see like a kind of like a white powder on it, well, that is essentially aluminum's version of rust, right? It's the oxide, right, coming out, and you need to clean that off. And the further you get down through that oxide layer, all right, the better your weld is going to be. You can actually see some of it floating around in the toes of your welds and things like that. It's pretty fun. So I used to work in education, so I love this aspect of welding. And if you guys have questions, please hit the comments section down there, and we'll get to it. But right now, I really want to get started on this thing. So what I do is I've got some acetone, some denatured alcohol, a couple of Scotch-Brite style pads, and I'm going to show you guys some tricks, right? All right, you guys, so check it out. These are some of the things that you need when welding aluminum, right? Obviously 4043, I'm going to run a 332 wire. This is an 1/8" plate here. Usually when it comes to aluminum, a little bit fatter wire is okay, but you don't want to deposit so much material at once that you cool your puddle too rapidly. So there is a right size, essentially, but with aluminum you can go up. When it comes to steel, like I don't really run anything over 1/16 in steel, and I actually prefer smaller diameter wires for very small welds, especially when you get into stainless steel. I'm going to show you guys hopefully that stuff later on down the road. Either acetone or denatured alcohol. Now, having worked for a very large manufacturer in aerospace, we did use acetone there. Now, some people say that acetone leaves a residue behind. So if you want to go that far, it's really a game of how extreme do you want to be. And I'm going to explain that here a little bit. If that's a problem for you, but for the home guy like me, acetone is just fine. It's more than enough. Denatured alcohol doesn't leave anything behind, okay? All right, and then I have two different versions of Scotch-Brite here. Some people prefer this, but it does tend to wear, and it will leave basically something behind inside of your material. So personally, I prefer stainless steel wire brushes almost exclusively when it comes to aluminum. But Scotch-Brite, you can prepare an edge, and I've got some cool tricks. Like if you're doing a single plate, you can fold the Scotch-Brite over it like that, and then you slide it back and forth while keeping it like lubricated essentially with acetone or denatured alcohol. Realistically, you can just soak your stainless steel brush and then scrub out your joint, right? And I prefer that because it gets down to the joint. Like after something's tacked like this, I can still clean it. Now, and just a notice, right? I know that some guys will try to claim that you must only go in one direction when pushing with your wire brush. That seemed to never be a problem for us, and the manufacturer that I worked for was quite large, and they never really made any difference. Now, what they're referring to when people say you only need to push one direction instead of push-pull, which I go back and forth, I'm trying to be a little bit aggressive. But they're talking about what's called burnishing, right? You're actually, they say that you're claiming you're embedding materials that you just cleaned out. You're pushing them right back into the joint. I didn't really find that to be the case. I have had years and years of my welds x-rayed and all grade A quality. So I don't really have that issue, and neither did we at a very large manufacturer. So it really is a game of how far do you want to go? How clean do you want to get it? How much time do you want to spend? When I worked for that company, I would spend 45 minutes to an hour cleaning about a 3-foot joint for 7 minutes worth of welding. Put that in perspective. So, all right, you guys, next comes the TIG setup, right? So, much as I love these big Furent cups and all of that, these aren't going to work for this particular setup. So I'm going to put these guys away. And when it comes to aluminum, I just opt for the go ahead with the pinkies. Now, in my opinion, when it comes to aluminum, you're looking for the smaller gas nozzle. All right, what this does is it constricts the gas flow out the tip, and that allows your arc to continue to be concentrated on the material. I've found that if you allow the gas to be kind of wide, it'll also allow your arc to get kind of wild on the outside. One of the other things that's very important when it comes to welding aluminum, the actual torch angle. You want to maintain almost a direct aim at what you're welding. If you start to lean the torch over and things like that, like you would for steel and stainless steel, you're going to get a lot of arc wander and possible arc strikes out in your HAZ or things like that. If you're not familiar with HAZ, that's heat affected zone, right? That's going to be the area right next to the toe of the weld that's been affected by the heat, but not actually penetrated into by the filler material you've added, things like that. I like pinkies. I keep a couple here, right? I have a little aluminum block I made with different tungstens. I'll take all of these over to the sharpener. I chuck these up in a drill. I'll show you. And I sharpen a bunch of them at once. That way I can just rock and roll. Now, when it comes to aluminum, you want to do what's called a truncation on the tip, truncate the tip, all right? Which basically just means you're going to grind it somewhat sharp and then just tap the tip to take the very, very, very tip off. What happens is that alternating current is very powerful, right? It comes down this tungsten and it explodes out the end. And what it does is it explodes the smallest portion of that tungsten right into your weld, and it will show up in x-rays, okay? So it will basically blow out your tungsten if you allow it. Alternating current uses a lot of juice. So like when you're in your house trying to weld and things like that, you're gonna be getting your walls hot almost welding with it. And that's a part of the other problem. So usually you don't see a lot of 110 volt aluminum welding, right, per se. You can do it with stainless steel and get away with it, but aluminum really requires the power. So when it comes to this, I like a little bit too much power, and then I can use my foot pedal to regulate. In a perfect world though, you want to know what your settings are exactly. That way you can flat foot this pedal and you're supposed to just cruise. You're not really supposed to pedal pump and things like that. But those are high-end tricks and things. So and we take that stuff very seriously. So the foot pedal itself is a potentiometer, right? So the more you push, just like your car, the faster you're going to go, more heat you're going to get out of this thing. So small diameter cup, lots of juice. So on this 1/8 inch aluminum right here, I'm going to be right around probably just under 200. I might run about 160. I'll see where it welds at, 160 amps. And then you want your alternating current balance at about 3 right here. But when it comes to aluminum, that's what this one is actually for, your balance, right? So as the sine wave is alternating, right? Okay, it's divided, but not divided down the middle. It'll either favor one side or the other as far as how much penetration versus how much cleaning action you're going to get. It's called dig. It's got a bunch of different names, but technically it's just AC balance. In the old days, they used to run green tungsten. That's what it was for. Your red thoriated tungsten is not necessarily made for aluminum. It will do aluminum, but I get a lot of arc wander when I weld aluminum with thoriated, so I don't really prefer it. I have the nice pink from our friends at Blue Demon, and I'm going to use that. That's like a hybrid type. And they tend to work pretty good on thinner aluminums. It's getting into the thick stuff where you're going to start to want to research different tungstens that can withstand the power you're about to put through it. And the alternative to that is adding helium to your mix. I'm going to run pure argon in here for this thinner stuff. That's not too bad. But if you want to get into welding like heavy aluminum, adding a bit of helium makes all the difference in the world. So it gets a chemical reaction that raises the temperature rather than using like amperage, right? So let's get ready to rumble. So I'm gonna get to cleaning, and then what I want to do is I want to add tack welds between all of these. One of the things about aluminum is it likes to move a lot. It distorts. I've hit it and almost immediately it starts wanting to bend and do things. So you pretty much need to lock aluminum into place. That's one of the tricks. So I'm going to add tack welds between each of these just to reinforce it. I can kind of tap it around. Now use a soft dead blow hammer or something like that if you need to move a joint. I have one over here that's a little bit large. I'm going to go ahead and try to massage it into place before we go ahead and weld it up, right? Ideally, fitment is everything when it comes to this stuff, but you don't always get good fitment. It's really hard. You try, but you know, you have to. But aluminum, open corners and things like this, you want them as close as possible because aluminum tends to be lackluster when it comes to penetration. Now, I've passed full penetration welds, full x-ray quality, blah, blah, blah. So I'm not trying to have that argument on the internet, but that's one of the characteristics of aluminum is it's essentially kind of hard to penetrate. It takes a lot of power. So if your joint is like overlapping and you're just putting a face weld on it, then you're gonna end up with like a high profile, lack of penetration weld. And tanks like this, like I said, they expand and contract. So that's where it will crack first and it's your fault. I'm kidding. This is a educational environment, right? That's what we're trying to do here. So. One of the things about aluminum, okay, when you're first learning it like this, is at first when you go to clean it, right, it'll be a little bit gummy, right? The wire brush will want to stick a little bit and things like that. What happens is you're getting through that oxide layer. Then all of a sudden, it'll get fairly smooth, right? Keep going, and then if you keep going after that, it'll start to polish. Once it starts to polish, that's essentially when it's ready to weld. So that's kind of what you're looking for. So, it's always a good idea, all right, when you're building something like an ice tank like this, so on and so forth, take a piece of scrap, strike a couple arcs against that, make sure your setup is right before you actually start working on your good piece, right? Just a good practice. It's also going to heat cycle your tungsten though. That was another trick. So that already blows off the tip. It blows it into a piece of scrap. If you have an issue like that, and those are showing up on your x-ray. So that's the name of the game. Let's heat cycle this thing. All right.